Hi, I'm Rachael Livermore at the University of Melbourne in Australia, and I'm joined again by Jeffrey Silverman in San Francisco, California.
And today we have on Dr. Natalie Gosnell, who is a professor at Colorado College in Colorado. And so she will be telling us today about her work on big groups of stars, stars dancing around each other, and occasionally crashing into each other. Welcome, Natalie.
Yes, thank you so much for having me. And yeah, I like studying what stars do when they get real interesting and what they're maybe not supposed to do sometimes.
Okay, that's pretty intriguing.
I study groups of stars that are all born at the same time, out of the same material, and are the same distance from us. And the stars that I study, the clusters that I study, are in the disk of our galaxy. So these are open clusters, as opposed to globular clusters, which are really massive star clusters that are orbiting outside of our galaxy. And so I use these clusters as a laboratory of sorts because I can't go and create my own star in a lab down the hallway from me. And so I'm relying on the galaxy to create some experiments for me and look at clusters at different ages and different distances and at different masses to test our ideas of how stars evolve.
So, how do you know when stars have crashed into each other?
When we study stars, we use something called a color magnitude diagram or a Hertzsprung-Russell diagram, where we're looking at the temperature of a star or the color of a star and how bright it is or its luminosity. And stars follow a pattern on this color magnitude diagram that's pretty expected, and where they fall in this pattern tells us how old the star is. Stars sometimes, though, fall off of this pattern. So there's something that's either changed their color or changed the brightness. And in those cases, that means that the stars have a really interesting history, and that history can include stars smashing together and colliding.
So I and many other people have studied some kinds of stars that smash into each other, then they can explode as a supernova. But that's not quite the kinds of collisions that you're looking at, right?
It could be. I think some of the binaries I'm looking at could end up exploding in the end. But most of the systems that I'm looking at are where you have two stars like our sun kind of coalesce into a new star. This new star is going to be more massive and brighter than it was before. And it sometimes ends up being called a blue straggler star, which is the majority of the types of stars that I study.
So, you said you're looking at stars like our sun that collide with other stars and merge. So, what is the likelihood that our sun would do that?
Thankfully, very little to no likelihood that our sun will do that because our sun is a lone star. It's by itself traveling through the galaxy. And the stars that I'm looking at are in binaries in clusters.
So we all worked together for a few years at the University of Texas, and since then, obviously, you've moved on to a new faculty position at Colorado College. What's different about that?
So many things. I mean, University of Texas is a really large research institution. It's a publicly funded state university with tens of thousands of students. Colorado College is a small selective liberal arts college with 2,000 undergraduate students, no graduate students, and it being a liberal arts college really lends itself to a different type of classroom environment. So my maximum class size is 32, but that's when there's two professors. If it's me by myself, the maximum class size is 25, and I taught quantum mechanics just recently, and I had 13 students in quantum mechanics. So it's a very different classroom environment, educational environment than undergraduates at UT Austin might receive.
Yeah, we're used to teaching like 200 at a time. So, yeah, that's very different.
Yes.
So, you work with a lot of undergraduate students at Colorado College. What kind of advice do you give them, and what would you give to people watching who might be interested in getting into astronomy?
I think the most important thing, if you're interested in graduate school in any field, is getting research experience in that field. Because I think a lot of undergraduate students don't understand necessarily that getting a PhD is a degree in research experience. It's not more classes. There's some classes along the way, but that's not really what a PhD is about. And so you don't have any experience in what a PhD looks like in your typical undergraduate education. And so finding a meaningful research experience where you're going to have some sort of ownership over the project and over a scientific idea is going to be the best example you can have of what a PhD is going to be look like and whether it's going to be the right thing for you. And maybe it's not going to be, and that's totally okay. But you're not going to know unless you actually get the opportunity to test it out. And so for me, when I was younger, that's why my summer research program was so influential for me. And that's what I always try to provide for my undergraduate students now is that little piece of research ownership, that scientific idea that they can test the waters with a bit and see if this whole grad school research thing is something that might suit them or not. And I make sure that the or not is totally okay with my students and with me. They're not going to disappoint me if they decide not to go on to graduate school. I just want whatever's best for my students.
Wow, that's really nice. You hear so many stories of people who felt afraid to tell their advisors that they maybe didn't want to go into or stay in astronomy.
Well, honestly, I mean, there are some people who think that that what I've done going and getting a faculty job at a small liberal arts institution is leaving the field.
Yeah.
Which I think is just fundamentally flawed and wrong in a lot of different ways because I'm still doing research.
Yeah.
I'm just serving a different type of student than faculty members at large institutions do, but it's something I really believe in, and I think it's still really valuable.
Well, thanks so much talking to us, Natalie. Your students are very lucky to have you, and it's really great to see you again.
Yes, you both too. This was great. Thank you so much.
Thank you. Cheers.
Cheers.